I want to, if you haven't been, if you're watching this for the first time, if you're new, let me just give you a quick little introduction to what kind of a program this is, or what kind of a course this is. I'm based out of the Zhongnan Center of Leiwen English in Nantong, Jiangsu. And ever since the coronavirus outbreak in February of this year, 2020, we had had to move our teaching systems online, and so normally these lessons I had been teaching them from the center before, real live audiences, mostly intended for teenagers and adults at the intermediate and above level. And due to the circumstances, we moved it onto this online WeChat Weisha platform, and we've been doing these ever since. Now, there is a clear benefit to doing recorded lessons. They can serve as a reference. You can watch previous lessons again and again and again. And my aim for you, those of you that are interested in improving your vocabulary because you have a goal to study abroad, or you have a goal to travel, or you work with foreign clients. My goal is to provide you with information that you probably wouldn't get otherwise, okay? So I have a long background as a researcher, as an amateur writer, and I've just been teaching and very interested in learning for many, many years. And so it's a great pleasure, a great privilege for me to be presenting these subjects. And I want to do the very best that I can. So, as I said, we've been teaching these since February. This is episode 16. And I want to just kind of give a quick little review of all of the topics that we've covered. Again, if you're new and you haven't seen any of the previous lessons, or you've missed a few and you're wondering, what you may have missed, as we go in the month of June, I'm a little all over the place here, and I want to welcome those who are actually here. Outsider, thank you for joining, and Emily, it's nice to see you here as well. Okay. We have a small audience tonight, understandably, on the evening before the Dragon Boat summer holiday. So I wasn't really expecting anybody to come. It was a surprise that you guys actually came. So I'm just kind of giving a quick little summary of what this course is, because we're now broadcasting on a new night, and we're entering into a new term. So I would expect new students, new audiences to be coming to these online lectures. And because we have about 4 months of history behind us, I wanted to kind of look back on some of the previous topics that we've actually covered. Invite you to come and watch these episodes. Again, in the month of June, right? We're in the month of June. This is June 24th. We're at the end of the month of June. And the way that the Practical English Lecture, online broadcasting, whatever you want to call it, Practical English, the way that Practical English has been structured is to provide a different topic for each week of the month, right? So we wanted to cover relevant topics and to be able to go into depth, a great comprehensive amount of research, not just gloss over the superficial, but actually try to systematically cover as much as can be covered without getting too specific. So but also if you focus on one topic, you sort of not everybody's interested in one particular topic. So for each week of the month, we cover a different topic, and if it's a topic that has a lot of information, we cover that for as long as we can. So in the month of June, we began with our first business English lesson, followed by our first literature English lesson, followed by our first geography English lesson, and now we're looking at a science English lesson. I just wanted, and with all of these lessons, they build upon previous lessons. These are vocabulary lessons, and I try to, when new relevant keywords are introduced, I try to give them to you through a worksheet, and I try to define them for you too. So if you're serious about improving your vocabulary, and you're a student at our school, and you come to these kinds of lessons, these lessons are custom designed are based around our courseware and based around the feedback and suggestions that have been given to me from students. So I just want to kind of quickly go through some of the previous lessons that have been taught this year that you can access for free on this app, right? And the first one was Infectious Diseases, where we looked at the coronavirus outbreak and other types of infectious diseases, influenza, bacterial infections. We talked about diseases here. As a microbiology lesson. We talked about bodybuilding or physiology and the science of strength, followed by nutrition, the science of eating healthy and the ingredients, the science of nutrition, how we can scientifically understand what food does, how it is processed by the body, and what kinds of foods are the best for us, and why. Okay, so these are lessons that you can review. You can go back and watch previous lessons. Introduction to popular music. We looked at musical genres and what defines a musical style or a musical genre and how music is made. Some of the theory behind it. Modern inventions. Some of the top 10 inventions that influence modern day society. A geography lesson, capital cities, where we looked at, I believe, 12 cities from 12 countries in the 6 main continents. Art and culture and architectural styles. This was a bit of a history lesson where we looked at the history of Europe, the history and evolution of civilization from prehistoric ancient Egypt and Sumeria all the way up until the beginning of the modern era, the end of the Renaissance. And we looked at the different architectural movements and how to describe the different architectural and artistic styles of these historical eras. And we looked at great speeches or introduction to the art of public speaking. This is a lesson that I highly recommend everybody watch. How to structure a presentation, how to outline and draft a speech, and how to research a topic, how to structure a talk, how to present a talk, just tips and best practices and ideas for how to improve your public speaking and writing. Eastern philosophers, the great philosophers Confucius, Lao Tzu, and the Buddha, the Eastern philosophers. We looked at Chinese National Day, or the National Day celebrated in October, October 1st, Chinese National Day. The history of how China was established. Modern-day People's Republic of China was established, the Revolutionary War. We looked at Eastern philosophers and Western philosophers. And this was a history of science lesson looking at from the origins, the early Greek philosophers and mathematicians and early thinkers. Science really wasn't a formalized academic discipline until well after the 17th century. Up until then, it was just a form of natural philosophy. So we had philosophers or polymaths, people that studied a wide range of different things, and they didn't have technological instruments. They had mathematics, but they some had greater interest in some areas than others, but many of them were interested in many kinds of things. Anyway, so this was under the right up until the scientific revolution, the 17th century, when religious thinking was very, very much the official way of thinking, up until the scientific revolution, when the scientific method, overtook religious thinking. So these people were philosophers. We looked at the Greek Aristotle and Galileo, Copernicus, Isaac Newton. The lesson that we're going to be teaching tonight is the extension of this one. Good evening. We are looking back at the previous 4 months, the last 16 lessons that we've taught. I expect to have on the new evening, now that we're broadcasting on Wednesdays, I expect that we will have a new group of students joining. So I thought that an appropriate way to begin on the new evening, on the at the beginning of the summer to term, to just kind of look back at some of the lessons that have been taught, to introduce the newer students to the previous content that I really would recommend that everyone watch. Before we go into the end of what has been the first month of this 4 lecture series. We're doing 4 concurrent lecture series. So the Industrial Revolution, another history lesson looking at how the invention of the steam engine and the coal-powered furnace and the locomotive and a few other types of machines prompted a technological and industrial revolution that, again, was the result of the scientific revolution, and this is what fundamentally, permanently changed our way of thinking about the world and our way of life, and we are living in the Industrial Revolution now. It's been ongoing ever since. So those were the lessons taught up until June, and now under the new structure, we are doing these 4 concurrent lecture series. One is the Business English, and lesson 1 of that series was Industrial Sectors Overview. So if you're interested in business English, this is where you need to start. Or you need to start with the Industrial Revolution lesson taught 5 weeks ago. The Industrial Sectors Overview is an important lesson. It's a survey, okay? And if you've noticed, we have been surveying. A survey is where you kind of look at everything very superficially, and then anyway, so it was a survey of industrial sectors, predominantly the manufacturing sector. We didn't look at the services sector. That can't come until we finish the manufacturing sector. So this is a lesson that looks at what are the main industries in the manufacturing sector. And next week is the week that we come back to this topic. So we'll be looking at the manufacturing of wood and paper and cotton, and I believe some food. Okay, and this is accompanied with video, so you'll get to learn a little bit about how these products are processed and made as well. This will be an ongoing lecture series going many, many, many weeks, because there are probably about 50 or 60 important industries in manufacturing and service, and my aim is to give you vocabulary, business-specific, relevant vocabulary through this lesson series, followed by the Introduction to Literature, survey of literary genres, and the elements of a story. So in 2 weeks' time, we'll be coming back to literature. And last week we did another geography lesson, so an extension of the original capital cities lesson. This was a lesson that this is a lesson series that intends to look at each of the cities in the United States, the 50 states, and a few cities in particular. We'll be looking at in greater detail those important historic cities and popular tourist destinations and so on and so forth. Tonight's lesson is the first or second lesson, if you like, on modern science. We'll briefly review the scientific method. We will be doing a survey of the main branches and sub-branches of science, so to provide you with vocabulary about particular scientific branches, probably some subjects that you are learning in school, those of you that are middle school, high school students taking physics and chemistry and biology. And you will be taking sciences, most of you, I expect, for another 8 years. And you will probably be specializing in different branches, specific branches. Those of you that want to be doctors, those of you that want to be engineers, and those of you that want to be computer software engineers or computer programmers. So in this lecture series, in this lesson tonight, we are doing a survey of all of those branches of science, sub-branches of science. And in future lessons, we will be looking in greater detail, sort of defining each of the, I think, important sub-branches. And also tonight, we will be doing a survey of the great scientists, inventors, and engineers from the end of the 17th century to the present day. There's probably a lot that I've missed, but I wanted to include some of the more recognizable ones. Probably the ones that I really missed are the social scientists, the economists, and the psychologists. This is what we're doing tonight. We're just doing a survey, an introduction, and when we come back to science in 4 weeks' time, we will be looking in greater detail at each one of the branches and sub-branches, as well as some of the great scientists that made important discoveries, or inventors that made important inventions within these sub-branches, right? So I don't know about you, but I'm pretty excited about that. So just to quickly recap, tonight our goal is to quickly review the scientific method, what makes a science, and what makes an area of study a formal science, or what makes a scientist, how does a scientist go about doing scientific work. Survey the main branches and sub-branches of science. Survey modern era from the end of the 17th century to the present day scientists, inventors, and engineers, and try to define some key terms as we go along. All right. So, what is the scientific method? Well, it's a way of investigating the natural world or universe. Scientists call that a phenomenon, something that happens that we can observe in the natural world. gain knowledge or correct and integrate previous knowledge. So scientists, take an astronomer, for example. Most of an astronomer's time is spent looking through a telescope or kind of reading the data sent back from a distant satellite or probe orbiting some planet, and taking the data and converting it into information or knowledge, and then trying to integrate that into previous knowledge. A doctor or a medical researcher is taking samples from patients, specimens, and so on, and doing an analysis of what kind of microbial organisms live inside the sample, and looking for anything new, looking for something new. It's kind of a boring task, right? But a necessary one, a systematic, necessary task is just looking for things that are new. And when something new is found, then, investigating it and coming up with a theory or a hypothesis as to what it is and where it came from, where it originated, and so on. Okay. Also looking at what is already known and testing it to ensure that it is, that the conclusions drawn, the information is well done. Like people make mistakes, so that's the process of correction. Scientists are constantly publishing to journals, and scientists are constantly reading journals. The information that is coming out each day and going back, several years, I guess, and just checking for errors and finding errors, and then having to go back and maybe redo the experiment and find that the experiment was not properly conducted, right? Sometimes we have to completely rethink our understanding of the world and the universe because scientists of the past made mistakes. Okay. So the scientific method is based on observable, empirical, measurable evidence. In other words, some phenomenon, some things that happen in the world, or some things that happened long ago, we're unable to do scientific research on these types of events because they're not observable, right? It has to be empirical and measurable. In other words, we have to have a large group of people able to, independently in a controlled way, do the same type of research, do the same type of experiment. You have to formulate a question that can be falsified. In other words, an experiment is sort of scientifically valid if it answers a question that can be falsified, can be proven to be true or false, basically. We'll get into, when we do a lesson on logic, which is one of the sub-branches, ties in with mathematics, kind of how that works. We won't do that tonight. Okay, so empirical research and experimentation. Empirical research is gaining knowledge through direct observation or experience. Experimentation, so the simple steps of conducting an experiment are: A, ask a question. Why is the sky blue? How many, why do the stars move in a certain way, or why does the moon move in the way that it does, right? Ask a question, make observations. So just actually look and record what you see. Form a hypothesis or propose an explanation about the question or phenomenon. So first you have to consider the question, make sure it's a sort of an observable question, right? A question that can be where an experiment can be done to answer the question, make some observations, come up with a theory or a possible answer to the question, and then conduct experiments that can prove that the hypothesis correctly answers the question. Okay? I wish I had a video to show you about this. I wasn't really able to find anything. Test the prediction hypothesis through controlled experiment. Okay, so these are the branches of science. There are the 4, 1, 2, 3. This one has 6. There's actually 4. The formal science, which is under this diagram, mathematical science. Then there are the physical sciences, which include the earth sciences and life sciences. Social science and applied science. So this diagram is helpful in a way. But think of it more along the lines of formal sciences, mathematics and logic and computer science. Formal sciences. Unlike other sciences, the formal sciences are not concerned with the validity of theories based on observations of the real world. Okay, so mathematicians okay, you have like the core of scientists are the natural scientists, the chemists, the physicists, the biologists. Okay, because these are scientists that do field research. They go out into the real world and they make real world observations. And then you have social scientists and mathematicians, and these people do something different, right? Mathematicians, they don't really make observations in the world. They look at patterns and numbers, and they come up with theorems and axioms, and they try to find equations that can serve as a model, or they will look at information taken from the natural sciences and try to abstract from the data, like theorems and axioms, give a kind of a mathematical formula that can express in like symbolic language something about the phenomenon, something that can be useful in making predictions, basically. Unfortunately, I'm not well educated enough on mathematics to really talk at length about it, but I've always been interested in it, and we will be coming back to that. Okay, so mathematics, logic, computer sciences. This is where some of my background lies in, computer science, and linguistics. As an English teacher, I'm very much interested in linguistics as well. Linguistics is the science of language, grammar, and the meaning of words, and how meaning can be communicated in words or in other ways, how language evolves, the differences between the different languages. You could say that it's a social science. It is, but the grammar aspect is kind of a formal science. Natural science. Some of this will also become clear when we look at some of these scientists and the discoveries and inventions that they made. So the natural sciences are the main core of science, right? It tries to explain and predict nature's phenomenon based on empirical evidence. So these are the scientists that go out into the real world and do field research and compile all of their findings into reports. What are natural sciences or life sciences? Biology. I don't know if you can see that or not. Anatomy, botany, so ecology, epidemiology, evolutionary biology, genetics, marine biology, micro or molecular biology, pathology, pharmacology, physiology, immunology, kinesiology, neurobiology, neuroscience, and zoology. Biology is the study of plants and animals, and microbiology are the microorganisms, bacteria and virus. Okay, outsider, I see your messages here. Something is wrong. Should be corrected. Okay. How to explain the black hole? Astronomy. I can explain that a little bit. I can present it better as a video, actually. And outsider, I'll let you know when we have an astronomy lesson. That will be coming up. And we're just doing a survey tonight of all of the branches of science. So biology is the life sciences, where we study living organisms. Evolutionary biology looks at how living organisms are adapted to their environment. So, we as human beings are separate from the rest of the animal species because we look different and we have a different, brain capacity. So we're able to study other animals and look at how other animals are different from other animals. What is the evolutionary purpose of, the features of an animal or the behaviors of an animal? Anatomy is the study of the parts of an animal. Botany is the study of the parts of a plant. Molecular or microbiology is the study of the cells. Molecular biology may be chemistry as well. Biology and chemistry are closely related. Okay, this is the earth sciences. Cartography is the study of map making. Environmental science is the study of how changes in an environment affect the different kinds of species. Or you look at an environment or an ecosystem or a habitat, and what kind of animals and plants and insects live in that kind of environment. And of course, how what is good for the health of an ecosystem or a habitat. Geography. Geology is the study of rocks and, say, soil. Mineralogy is the study of metals. Oceanography is the study of oceans. Paleontology is looking at the natural world, but looking at it through artifacts, like historical artifacts. So those people that go looking for dinosaur fossils, those are paleontologists. Seismology is the study of tremors, or how earthquakes happen. Okay, those are the earth sciences. Chemistry is a physical science of atomic matter, especially its chemical reactions, but also including its properties, structure, composition, behavior, and changes as they relate to chemical reactions. This is the periodic table of elements. It is believed that all matter is made up of combinations of these basic elements. We can see hydrogen, and we can see carbon, nitrogen, oxygen, helium. These are the very, very common building blocks of life here. And then we have those kind of rare minerals. Some of these are micronutrients that we need in our body. Some of these are toxic. Some of these can be combined to make, materials like iron and steel and plastics and so on. Okay. Chemistry. Biochemistry is the, combination of biology and chemistry. Medicinal chemistry or pharmacology, looking at how medicines can cure illnesses. Neurochemistry, the kind of chemical reactions that take place in our brains. Nuclear chemistry, geochemistry, electrochemistry. These are all fascinating subjects. Physics. The physical science that studies matter and its motion through space and time and related concepts such as energy and force. Acoustics is the physics of how sound travels and how sound and vibration moves through space, or moves through a medium, I guess. Atmospheric physics, the physics of, I guess, gravity and friction change at higher levels of our atmosphere, and then you get into outer space, and physics change once you kind of leave the atmosphere, and enter into like a low or zero gravity space. Atomic physics also, like the physics change when you get down to the atomic level, where things are very small. They're not really subject to the forces of gravity anymore. Molecular physics, electromagnetism, mathematical physics, mechanics, quantum mechanics, nuclear physics, and relativity. So as promised, when we come back to the science lessons each 4 weeks, we'll be looking at some of these sub-branches in greater detail. We're just kind of doing a survey tonight of what they are. Outside of this is astronomy. Studies the universe beyond the Earth, including its formation, development, and evolution. Physics, chemistry, meteorology, and motion of celestial objects. So charting the night sky, looking at the stars. And phenomena that originate outside the atmosphere of the Earth. So the sub-branches are astrobiology, astrodynamics, astrophysics, planetary science, social sciences. So if the natural sciences, chemistry, biology, physics, and the earth sciences are the core of science, and mathematics and logic and computer science are the formal sciences, social science is where we looked at everything else, like history and economics, psychology. This is a different kind of science because you can still use the scientific method and come up with hypotheses and, to some degree do experiments. But the kind of conclusions that we draw from the social sciences are debatable, speculative. It's just it's a different kind of a area of research, and a newer one as well. Like social sciences were one of the last of the sciences to develop. So a social science is the study of the social world constructed between humans. Social is the concept of exchange of ideas or influence of ideas, thoughts, and the relationship interactions resulting in harmony, peace, self-enrichment, between humans. The scientific method is utilized mainly in social sciences, albeit adapted to the needs of the social construct being studied. Like one of the reasons why social sciences is a difficult, not a hard science, well, if you are, let's say you're a Western, you're a European social scientist, sociologist sent into the Amazon rainforest to study the tribal people of, living in the Amazon rainforest. You don't want to, like you can't study them like animals, because they're humans, right? And they have their own language and they have their own customs and culture and belief systems and so on. And their belief systems and customs and culture and language are every bit as kind of valid as a Western, European civilized researcher. In other words, the researcher, if they try to make judgments on another group of people, they are projecting their own biases. They are projecting their own feelings onto other people. This is what makes social sciences difficult. You have to formulate questions that can be falsifiable, and you have to come up with observations that everybody can make, and not everybody is able to make an objective observation because you can't get inside the mind of another person from a foreign culture. So you could say that linguistics is a social science because linguists do try to study and learn the languages of other peoples, and then through that kind of research, we get a better insight or a window into what are the beliefs and what are the ways of thinking of another kind of people. Social sciences in the modern day is really about collecting statistics. So looking at the shopping preferences and the habits and the day-to-day activities of groups of people in different parts of the world. That's kind of what sociology is, and how we can, and economics is how studying the buying habits, studying the behavior of markets basically is another social science. Linguistics, sociology, economics, anthropology. As mentioned, like an anthropologist is somebody who either studies historic peoples through like collecting artifacts from an archaeological site. I guess that's an archaeologist. An anthropologist is also somebody who visits foreign peoples, visits foreign cultures, and tries to understand them. And also looks at like the writings of other anthropologists and tries to synthesize that, I guess. Anthropology and archaeology is the study of other types of people, past and present. Cultural, okay. Ethnography is looking at the different types of like ethnic backgrounds of different people. Linguistics. Now the arts fall under the social sciences, and we can use some like scientific thinking or scientific reasoning when critiquing the arts. Okay, business studies, economics, management, marketing, civics, education, cognitive science, philosophy, psychology, sociology. Are really important sub-branches of the social sciences. Applied sciences, engineering, a branch of science that applies existing scientific knowledge to developing more practical applications, including inventions and other technological advancements. So an engineer or an inventor is somebody who isn't out doing scientific research, but is using scientific information in an applied way to build something. Agriculture, forestry, architecture, computing technology, energy technology, environmental science, forensic science, health science, nutrition, medicine, dentistry, business studies. These are all examples of applied sciences. Engineering, a discipline, art, skill, and profession of acquiring and applying scientific, mathematical, economic, social, and practical knowledge in order to design and build structures, machines, devices, systems, materials, and processes that safely realize improvements to the lives people. An aeronautical engineer is somebody who designs aircraft. Aerospace is, rocket ships, satellites. Bioengineering, doing genetic alterations, I suppose. Chemical engineering, coming up with new chemical substances and materials. Computer engineering, so designing computer systems like microchips and computer components, as well as software engineering. Electrical engineering, industrial engineering. Survey of some of the great scientists, inventors, and engineers of the past 300 years. Okay, so the first, or the last of the philosophers was René Descartes. He was a mathematician. He made important discoveries in analytical geometry, calculus, and other fields of mathematics. A philosopher and a mathematician, René Descartes. Blaise Pascal, a mathematician. Geometry is the study of, geometry is the mathematics of shapes. Isaac Newton. Made discoveries in mathematics, optics, physics, and astronomy. He wrote Principia Mathematica in 1687, which laid down the foundations for classical mechanics, explaining the law of gravity and the laws of motions. And was able to kind of explain some of the properties of binomial numbers, binomial equations. And Leibniz, a mathematician, innovator, philosopher. So he developed a mechanical calculator. He built a machine that later calculators were built from. He worked on advancing the theories of Descartes and Newton in the area of calculus, and a writer and philosopher. Benjamin Franklin discovered electricity. That's important. Benjamin Franklin discovered electricity. He was also an American statesman. John Wilkinson, an engineer, I think, helped in the manufacture of iron, so a geologist, perhaps, or James Watt, inventor of the steam engine. Okay, inventor of the steam engine, the locomotive. Well, the steam engine later that became the locomotive. Volta, Alessandro Volta, credited with inventing the battery. So the first electrochemical battery cell used zinc, copper, and an electrolyte, such as sulfuric acid and water. So after the battery was invented, after electricity was discovered and the battery was invented, they were able to conduct experiments and, invent electrical devices. Edward Jenner, a biologist, the pioneer of the smallpox vaccine, when smallpox was ravaging Europe and Africa and Asia, China, I think. Jenner looked at how people who recovered from smallpox, he took their antibody specimens and through that research came up with the theory of immunization, inoculation, putting in immunizing people through vaccination. Carl Gauss was a mathematician. he just advanced the ideas in algebra, statistics, differential geometry. He was a brilliant mathematician. Charles Babbage, inventor or creator of the first mechanical computer. So Leibniz invented the first mechanical calculator, and Babbage invented the first programmable mechanical computer. Faraday, Michael Faraday, was the English scientist who helped, Faraday invented the electric generator, and it says here he helped convert electricity into a format that could easily be used, stored in a battery, I guess. I did a lesson on Faraday and Newton. Look at the lesson on modern inventions to learn more about Faraday, and the lesson on the natural philosophers for the lesson on Newton. Perhaps we'll come back to them. Perhaps we should. Samuel Morse invented the early telegraph. The telegraph was the precursor to the telephone. He invented Morse code, which was the binary code today is the language that computers use to transmit information. Morse code was a form of a code that had like long and short pulses, electrical pulses that could be translated into kind of a shorthand code or language used during the First World War a lot. Okay, William Talbot was the pioneer in photography. Charles Darwin. Charles Darwin developed the theory of evolution, published The Origin of the Species. Louis Braille developed the Braille system, allowing blind people to read. Henry Bessemer, just another engineer, who was that other one? Like Watt and Wilkinson, just furthered the, it says, inventor of the method of producing steel. So in steel production, they talk about a Bessemer, the steel production is named after this person. Blowing air through molten pig iron, which improved the quality of steel and lowered the cost. Okay. The name escapes me here. Aydah Lovelace, one of the few but great female scientists, English mathematician, had a love and interest in math and logic, and worked with Charles Babbage on writing one of the first computer algorithms. Very pretty. Louis Pasteur, like Jenner, biologist, contributed substantially towards the advancement of the medical sciences, developing cures for rabies and anthrax and other infectious diseases, and understood the risk of sort of like bacterial contamination, enabled the process of pasteurization to make milk safer to drink. Maxwell, James Clerk Maxwell, developed color photography. Talbot and Maxwell. I think some of the early photography companies were named after these people as well. Nicholas Otto, German engineer who developed an effective internal combustion engine, the engine used in the automobile. Otto developed the four-stroke engine with the spark plug, represented a huge leap for non-coal-based engines, petroleum. So the engine that was the internal combustion engine that used petrol used in cars. The automobile was named after that guy. Alfred Nobel, the Nobel Prize, Swedish chemist, engineer, and armaments manufacturer. He developed weapons, bombs, and so on. Later became a kind of an advocate for peace. The Nobel Prize is awarded to people who make the world safer. Nobel invented dynamite and held 350 other patents, including a gas meter. Anyway, he's most famous for his legacy of Nobel Awards. He decided to make an international organization that awarded prizes, recognition, funding to scientists who did work for the advancement of humanity rather than furthering private interests, I guess. Nobel Prize. Eiffel, another engineer or architect, designed the Statue of Liberty. Daimler, another automotive engineer. The Daimler Chrysler Company is named after him. Developed a liquid petroleum-fueled engine. Dimitri Mendeleev, one of the Russian scientists. There's quite a lot of Russian scientists. I didn't include them here, but this guy formulated the periodic law and standardized the periodic table of elements, the chemistry table of elements. Carl Benz, Mercedes-Benz, German inventor and businessman, developed another petrol-powered car. So, Mercedes-Benz is named after this inventor, this engineer. Thomas Edison, another inventor, most well-known inventor, filed over 1,000 patents and innovated. In other words, he improved the technologies. There were a lot of patents and technological discoveries being made. He looked at the ones that he thought were practical, useful, and tried to improve them. One of his best-known inventions was the filament light bulb, the phonograph, which is a record player, and motion picture camera. Alexander Bell invented the first working telephone, telecommunications. Nikola Tesla, a physicist who invented fluorescent lighting, the Tesla coil. We'll have to come back to Tesla. He was considered to be well ahead of his time in his electrical inventions. Max Planck, a mathematician, theoretical physicist, who contributed in the development of quantum mechanics. Henry Ford, Ford Automobiles, another engineer, inventor, pioneered the use of mass production for motor cars, helping to reduce price and make cars affordable. He introduced on a mass scale the factory assembly line, revolutionizing the efficiency of building cars. Probably come back to, maybe we'll do a lesson on cars and look at Benz and Ford and Otto and Daimler, maybe history of cars and how they work. That would be interesting. Marie Curie, one of the few female scientists and one of the most intelligent scientists, I think. Winner of over 4 Nobel Prizes, and had a son that won 2 Nobel Prizes, I think. Definitely come back to her as well. French chemist and physicist, discovered radium and helped make use of radiation and X-rays. Sigmund Freud, the physician and leading figure in the new science of psychoanalysis or psychology. made an extensive study into the dreams and the subconscious to try and understand better human emotions. He looked at people who were mentally sick, or he didn't look at. He worked with people who were mentally sick and tried to speculate as to what caused their sickness. And he speculated that it was childhood trauma, and the symptoms of their mental sickness were phobias, irrational fears that were born out of a childhood trauma, basically. Sigmund Freud. The Wright brothers invented the airplane in 1903. It could only fly about 3 feet off the ground due to the materials that they had. And I'm back. But I lost you guys. Now you're still here. I don't know what's going on tonight. Hopefully this is being recorded. Not this guy. This guy invented the radio. Guglielmo Marconi invented the radio. And, studied the use of electromagnetic waves. Otto Hahn, a chemist, discovered nuclear fission. Alexander Fleming discovered antibiotic penicillin. Albert Einstein revolutionized modern physics with his discovery of the general theory of relativity. Niels Bohr, another physicist that looked at the structure of the atom. Inventor of the television here, John Logie Baird, inventor of the television. Enrico Fermi, the inventor or the scientist who developed the nuclear reactor, which led to the creation of atomic bombs. Oppenheimer, Robert Oppenheimer, in charge of the Manhattan Project, which led to the creation of the first atomic bomb. Rachel Carson, conservationist. So America was being torn apart by industry, and she was the first environmental scientist who advocated for conservation, the need to keep forests and the need to protect animal species. Conservationist and writer, a marine biologist who used her knowledge to become a pioneering environmentalist. Her work Silent Spring highlighted the dangers of unregulated pesticide use, the spraying of chemicals on crops. Played an important role in creating the modern ecological movement. Alan Turing, computer scientist, considered the father of computer science. Most of these individuals we will be coming back to in depth. We're just doing a survey tonight. Qin Xiang Wu, I'm very sorry about the pronunciation there, a Chinese-American experimental physicist also working on the Manhattan Project. I guess we can look at the Manhattan Project and the invention of the atomic bomb. Richard Phillips Feynman, a physicist, pioneer in quantum computing and the concept of nanotechnology. Rosalind Franklin, a biologist or a British chemist, making contributions to the understanding of the structure of DNA. Noyce, an electrical engineer, invented the microchip and integrated circuit. So, modern computers developed by Richard Noyce. James Watson, molecular biologist, discovered DNA. Noam Chomsky, a linguist, made some important contributions in the study of linguistics, developing a framework of universal grammar. So when we come back to linguistics, we'll be looking at some of the linguists like Noam Chomsky and others. Neil Armstrong, the astronaut, aeronautical engineer, studied engineering through his service in the Navy, and went into NASA's space travel program and became the first man to successfully land on the moon. Jane Goodall, anthropologist, a humanitarian environmentalist. Okay, so she spent many years observing the behavior of chimpanzees in their native habitat, and her publications radically altered the public perception regarding chimpanzees and ape species. So cute. We're almost at the end here. There's Stephen Hawking, physicist, cosmologist, authored The Theory of Everything and A Brief History of Time, suffering from cerebral palsy, a degenerative musculoskeletal degenerative disease. Richard Dawkins, an evolutionary biologist and author, popular science writer. Steve Wozniak, American inventor and electronics engineer, co-founded Apple Computer with Steve Jobs, primary electronics engineer who designed and developed Apple II in 1977. Tim Berners-Lee, computer scientist, inventing the World Wide Web, the Internet. So we'll have a lesson on computers and computer science, and we'll look at Steve Jobs and Wozniak and Berners-Lee and Babbage and Turing, I think, all together in one lesson maybe. Steve Jobs. And I've talked about Jobs quite a bit. I'll be talking about Jobs in the computer lesson, I think. How Jobs' ideas about computers popularized the way computers were designed, marketed. Elon Musk, entrepreneur, IT specialist, engineer, got very, very wealthy off of setting up PayPal, which is an online commerce banking system. And then he innovated pioneering engineering programs such as these electric cars, and now he's working on space exploration. And that's all, okay? That's all of them. So, apologize for the technical problems that we were having earlier. I'll be uploading the slides for you to read for yourself on the study group in a few days. That's all. Enjoy your holiday. I really do thank you for coming tonight. I was not expecting to have as many people come as we had tonight, so that's very encouraging. Anyway, that's all I have to say tonight. If you have any questions, please do feel free to reach out to me. I always respond. And next week is industries. Okay? Thank you, Emily, and everyone else. Talk to you soon. Goodbye.